So now we're going to do a problem that's very similar to the problem on the homework that screwed a lot of people up. And that was the one with the tongue rolling. It was a little confusing because it's asking you to make a jump that we didn't necessarily make in class, but it's expecting you to understand what it means when a trait is inherited dominantly or recessively. And so this question, like that question, says 75 out of 200 people have widow's peaks, which are inherited as a dominant trait. We want to calculate the allele frequency and the genotype frequency. However, I just realized that I forgot a very important point. In order for this to work, the population has to be at Hardy-Weinberg equilibrium, and we have to state that the population is at Hardy-Weinberg equilibrium in the problem. Okay. So when we know the populations in Hardy-Weinberg equilibrium beforehand, we can go back and forth between these two equations to find allele and genotype frequencies as needed. Because we know if the population's in Hardy-Weinberg equilibrium, those 5 assumptions are held true, variation is maintained, and the population is not evolving. Allele frequencies are not changing from generation to generation. So what do we know? We have 75 out of 200 people that inherit widow's peaks as a dominant trait. What does that mean? And this is what tricked most people. We know that 75 out of 200 is equal to big W, and big W, little w. It's inherited as a dominant trait, which means that it's both the homozygous dominant and the heterozygous. We can't do anything with this yet. I mean, we know this, but we can't do anything with it. So what can we do? Well, we can find the missing piece of the puzzle. So if we know 75 out of 200 are these two, what's left? 125 out of 200 have got to be homozygous recessives. Well, what do we do with this? Well, what is WW in one of these two equations? It's not Q. A lot of people think it's Q. It's not Q. It's Q squared. Because this is a genotype. And when we're looking at genotypes, you should automatically think, that's the Hardy-Weinberg equation. That's not the allele equation, because we're not looking at alleles. If we were looking at big W and little w, we'd be looking at alleles. So this guy, little w, is equal to Q squared. And we know this to be true because the problem states the population is at Hardy-Weinberg equilibrium. I know I'm being very repetitive, but I want you guys to get this. So if we know Q squared, how do we find our allele frequencies? What do you do when you need the original of something and it's squared? You take the square root. So 125 out of 200, let me just do that math real quick for you guys. That's 0.65. Take the square root. And that'll give us Q, which is equal to 0.79. Aha! So now we have to do it the shortcut way because we don't have a way to calculate P by itself. So we have to do 1 minus Q to get P from that allele frequency equation. So 1 minus Q is equal to 1 minus 0.79, which is equal to 0.21. And that's our P. So that's our big W. So now we can come up here and write big W, 0.21, little w, 0.21. 0.79. Those add up to 1, so that checks out. What we can do now is erase all this mess. Because now what we want is to find our remaining genotype frequencies. So what about that big W and that big W little w? Where are they? What percentage of the population is homozygote dominant and homozygous or heterozygous? Let's figure it out. So this is easy. You just plug and play. You take these numbers that you just found for our allele frequencies and you plug them into the Hardy-Weinberg equation. Why? Because we know the populations at Hardy-Weinberg equilibrium. You guys should be reciting this with me at this point. All right. Okay. Well, we need to find our genotype frequencies. We know our Q squared from before, right? That was our 125 out of 200 people. So we need to find these two. We need to find our big W and our big W little w. Our homozygote dominant and our heterozygote. So for P squared, we just plug it in and square it. And little numbers, when you square them, look weird. So if you get a smaller number than what you started with, or just, it's okay. Just make sure they add up to 1. So 2 times 0.1 times 0.79. 0.33. So now we have all our pieces. So what are they? So our P squared is our big W. So those are our homozygote dominants. And that genotype frequency in the population is 0.04. Our 2PQ are heterozygotes, and that genotype frequency in the population is 0.33. Our little w, or our recessive homozygotes, are 0.625% of the population. And those three numbers should add up to 1. And for this problem, that's all you need to do. We wanted the genotype frequencies and the allele frequencies. And we got them.